Establishing a priority scale for passenger ship terminal renovations to improve services using AHP method. Abstract: the port is one of the transportation nodes in the logistics system that has a strategic role. However, the current condition of ports in Indonesia is still far from expected, causing port services to not provide optimal support in supporting the national logistics system. Therefore, it is necessary to plan and control ports to support the national logistics system. This research studies the selection of priority scales for improving port facilities at Tulehu Seaport, Maluku, using the AHP, Analytical Hierarchy Process, method to improve passenger port services at the passenger terminal. The analysis criteria are divided into three, namely, mobility, service, and room. AHP advises that effective spatial planning is a top priority to be implemented. The results of this study can be considered by the government/passenger terminal manager to take appropriate actions according to the passenger's needs. Keywords: AHP, Passenger Terminal, Decision, Tulehu Seaport, Priority Scale. Introduction. Sea transportation serves to serve the mobility of people, goods, and services that connect economic activities between islands and international relations, while air transportation serves to serve fast transportation between islands and between countries for people, goods, and services, as well as connecting isolated areas, remote areas, and border areas that have not been connected by other modes of transportation. 1. Tulehu Seaport serves domestic shipping with a large number of passengers. The location of Tulehu Port is very strategic for connecting islands in Maluku province, see Figure 1. The Indonesian government has a national strategic program, Maluku as the National Fish Barn 2-3. As the impact of this policy, the Maluku local government must prepare supporting facilities to accelerate the national strategic plan, namely the Tulehu Seaport 4. Tulehu Harbor is a very busy port, especially before Christmas. Passengers at Tulehu Harbor, Salahutu District, Ambon Island on D1 Christmas celebrations exploded. As a result, officers, both at the airport and the police at the port, were observed to be overwhelmed with regulating inter-island departure activities. Monitoring, Saturday, 24/12, the number of passengers at the Tulehu port was booming because it was used for crossings to Haruku Island, Saparua, Nisalaut, and Amahai Port, Seram Island, Central Maluku Regency. Airport officers intensively monitor the loading capacity of fast boats, especially those operating to the ports of Amahai and Haria, Saparua Island 5. The number of passengers has increased every year, as shown in Table 1. This is presumably due to an increase in public interest in using fast boats. In addition, the phenomenon of long school holidays and holidays is the cause of people traveling by ship. On the other hand, the limited number of fast boats means that many passengers, be it the public or domestic and foreign tourists, cannot be transported every day. The Maluku regional government plans to add a fleet of fast boats to serve the increasing number of passengers. In this research, comprehensive research will be carried out related to determining the priority scale for the renovation of the passenger terminal, including mobility, services, and rooms using the AHP method. With the existing data, the development of the Tulehu port, Maluku will be carried out in order to meet the feasibility of the passenger terminal to operate properly. 2. Literature study. A. Tulehu Seaport, Maluku. Harbor is everything related to the implementation of port functions to support the smooth, security and orderly flow of ship, passenger, and/or goods traffic, sailing safety and security, intra- and/or intermodal transfer sites, and to encourage the national and regional economy while still paying attention to regional layout. Tulehu Harbor is located in Salahutu District, Central Maluku, Maluku Province, Indonesia, and is the gateway for residents from the islands of Saparua, Seram, Haruku, Nisalaut and other islands to Ambon City. Tulehu Harbor has an area of about 3 ha. There are 3 fleets of ships that serve inter-island sea transportation based at the Tulehu port, namely speed boats, wooden boats, and large fast boats over 100 GT. Speed boats are small vessels, under 7 GT, made of fiber, with a 40 HP engine. Speedboat is a means of inter-island sea transportation by residents of the Lease Islands, which has been going on since the 1980s, covering Saparua Island, Haruku Island, and Nisalaut Island. Compared to wooden boats, speedboats are more suitable for use as a means of transportation because in addition to faster travel times, they also pay attention to aspects of sailing safety. When compared to large fast boats, speedboats have a more flexible departure schedule, because they do not have a fixed departure schedule. At any time residents can use a speedboat with a maximum passenger capacity of 5 to 6 people. 7. B. Analytical Hierarchy Process, AHP. The Analytical Hierarchy Process, AHP is a concept, tool, technique, or method in making decisions for complex, unstructured and multi-attribute problems by ranking the available decision alternatives and then choosing the best one with the criteria set determined by a numeric value. AHP is a decision support model developed by Thomas L. Soddy, a mathematician from the University of Pittsburgh, United States in the 1970s. This decision support model will describe a complex multi-factor or multi-criteria problem into a hierarchy. AHP is widely used in decisions for many criteria, planning, resource allocation, and prioritization of the strategies that players have in conflict situations. With AHP, a complex problem can be broken down into groups which are then arranged into a hierarchical form so that the problem will appear more structured and systematic. Muliano 10. The principles used in solving problems with the AHP method are as follows. 1. Decomposition. This principle is the solution of complete problems into their elements to form a hierarchical decision-making process where each element or elements are interconnected. If you want to get accurate results, solving is done on the elements until it is impossible to do further solutions so that several levels of the problem are obtained. The decision hierarchy structure can be said to be complete and incomplete. A hierarchy is called complete if all elements at one level correspond to all elements at the next level, while an incomplete decision hierarchy is the opposite of complete. The form of the decomposition structure is, the first level, decision objectives, the second level, the criteria, and the third level, the alternatives. 2. Comparative judgment. This principle provides an assessment of the relative importance of two elements at a given level in relation to the level above it. This assessment is the essence of using the AHP method. This assessment can be presented in the form of a matrix called a pairwise comparison matrix, which is a pairwise comparison matrix containing the preference levels of several alternatives for the criteria. 3. Synthesis of priority. In this principle, it presents a pairwise comparison matrix which is then searched for the eigenvectors to get local priority. Because the pairwise comparison matrix is present at each level, to get the global priority, we can synthesize between the local priorities. 4. Logical consistency is the most important characteristic. This can be achieved by aggregating all the eigenvectors obtained from the hierarchical levels and then obtaining a weighted composite vector that results in the decision-making sequence. 3. Method. This study uses a combination of qualitative and quantitative methods. The qualitative method is used when measuring the relative between the factors that affect the passing grade/passing threshold and the checklist from primary data. While quantitative methods are used to carry out hierarchical rankings and calculate the weighting of each criterion. A combination of qualitative and quantitative methods was used when validating the research results by comparing the results of the AHP analysis and the results of interviews with stakeholders at the research site, among others. Stage I. This stage is the preliminary stage to formulate the criteria and sub-criteria of the factors needed to carry out renovation/improvement of the Class 2 Tulehu port obtained from primary data, questionnaires and interviews. Stage 2. This stage is the stage of formulating the dominant criteria and sub-criteria formed from the AHP method to obtain the factors that determine the need for renovation/improvement of the Tulehu Class 2 port. Stage 3. The AHP analysis stage is the analysis of primary data results from Class 2 Tulehu port service users. Furthermore, the AHP method is used to determine the priority scale of decision-making from the available data. AHP analysis of Tulehu Class 2 passenger port terminal facility needs based on a study of social and economic aspects as shown in Figure 5. The AHP hierarchy model in this study consists of 1. Criteria, 2. Sub-criteria, 3. Alternative criteria and sub-criteria for the need for Class 2 Tulehu passenger terminal port facilities consist of 1. Mobility criteria. Which of the following mobility sub-criteria is the most important in fulfilling passenger terminal facility needs? A1. Passenger mobility in comfort. A2. Passenger mobility effectively. 2. Service criteria. Which of the following service sub-criteria is the most important in fulfilling passenger terminal facility needs? B1. Service with online check-in. B2. Service by checking in manually. 3. Room criteria. Which of the following room sub-criteria is the most important in fulfilling passenger terminal facility needs? C1. The room needs to be expanded. C2. The room needs a spatial change. Furthermore, the steps/alternatives that need to be taken to meet the needs of Tulehu Class 2 passenger terminal port facilities are 6 activities that need to be carried out, including 1. Providing internet access. 2. Adding counters. 3. Doing effective spatial planning. 4 additional passenger seats. 5. Provide a comfortable/cool room by installing a fan/AC. 6. Expanded room. The steps and process of process hierarchy analysis, AHP, are as follows. 1. Defining the problem and setting goals. If AHP is used to select alternatives or develop alternative priorities, at this stage the development of alternatives is carried out. 2. Arrange problems into a hierarchy so that complex problems can be viewed from a detailed and measurable perspective. 3. Prioritization for each problem element in the hierarchy. This process generates the weight or contribution of elements to the achievement of goals so that the element with the highest weight has priority for handling. Priority is generated from a pairwise comparison matrix between all elements at the same hierarchical level. 4. Conducting consistency testing on comparisons between elements obtained at each level of the hierarchy. 4. Result and discussion. This principle means making judgments about the relative importance of two elements at a given level in relation to the level above it. The results of this assessment are more easily presented in the form of a pairwise comparison matrix. A criteria sub-criteria. The results of the questionnaire that have been distributed to Class 2 Tulehu port users are shown in Table 2-3. The priority scale for the need for Tulehu Class 2 passenger terminal port facilities is shown in Figure 6, where the order of priority is Rungan with a weight value of 0.56, the second priority is services with a weight of 0.35 and the third priority is mobility needs of 0.09. Furthermore, to validate the calculation of the priority scale, eigenvalue, the consistency index, CI, and lambda values are calculated in the CI formula as follows. Calculations using the decision analyst, obtained a comparison of the level of importance of the decision support factors as the AHP model Figure 6. The three main factors obtained. The value of inconsistency ratio obtained is 0.07-0.10 so that the model is considered quite consistent, acceptable, as a decision hierarchy model. The next stage is to look for subcriteria values to get more specific priorities, as shown in Table 5-7. In each criterion there are subcriteria to obtain a better decision. The subcriteria in each criterion are also analyzed and weighted, as follows. Analysis of the results of the questionnaire calculations by adding subcriteria shows quite detailed results. Furthermore, the results of the subcriteria questionnaire are combined with the calculation of the results of the criteria calculations as shown in Figure 7 and Table 8. B. Alternative. Furthermore, the steps/alternatives that need to be taken to meet the needs of the Tulehu Class 2 passenger terminal port facilities are 6 activities that need to be carried out. The questionnaire results details are in Appendix 3, as shown in Figure 8, including 1. Providing free internet access. 2. Adding counters. 3. Doing effective spatial planning. 4. Additional passenger seats. 5. Provide a comfortable/cool room by installing a fan/AC. 6. Expanded room. AHP as a decision-making method provides the necessary alternatives, actions, as shown in Figure 9, namely 1. The priority scale that must be done is to rearrange the room. 2. The passenger waiting room needs to be expanded. 3. Waiting room facilities must be equipped with fans/air conditioners. 4. Providing free internet access facilities in the port area for users. 5. The number of seats needs to be added to anticipate additional passengers. 6. Additional counters need to be made if needed. V. Conclusion. This study provides good input using AHP and provides good flexibility to propose analyzing various alternative options and guidelines on how to deal with real situations. This innovative measurement methodology will provide a more suitable analysis to determine which is a more important measurement factor, priority, which must be carried out by rearranging the room with a weight score of 0.210. This alternative has almost the same value as the expansion of the room and the provision of a cool room with a score of 0.207 and 0.201. In its implementation, of course, it must consider the availability of funds so that each alternative can be implemented by providing a good response for port service users and providing the maximum revenue contribution to port managers.